So last week we talked a little bit about the metric system. I'm going to quick review that. You guys have this sheet in front of you which has information about it on it. So the metric system uses meters to measure length, grams to measure mass, liters to measure volume. This is at the top of that sheet. Symbols for these: a meter is a lowercase m. Specifically a lowercase m. A gram, the abbreviation, the symbol, is a lowercase g. And a liter, the symbol is a capital L. Now I'm pointing out the case here because uppercase and lowercase does matter. And putting it into the computer in long kappa, if you use a lowercase l for liter, it will mark it wrong. It's a little annoying when you have the right answer, you have the right number, you have the right number of sig figs, you even wrote an L, but because it's not capitalized, it counted it wrong. Okay? So be aware of that. Capitalization does matter with these units. Okay? Now, in the metric system, everything is based off of those units right there, but we have prefixes which go in front of them, like kilo. If we have a kilogram, 1 kilogram would be equal to 1,000 grams. 1 kilometer is equal to 1,000 meters. 1 kiloliter is equal to 1,000 liters. And kilos right up here and here. 10 to the power 3 is 1,000. Mega, capital M for the symbol, that would be equal to 1,000,000 of whatever we're talking about. So a megagram would be 1,000,000 grams. Megameter would be 1,000,000 meters, so on and so forth. Giga, 10 to the power 9 is a billion. So we have 1,000,000,000 meters or 1,000,000,000 grams. We have a gigagram or a giga meter. Going smaller. Here's where they get smaller. Deci, 10 to the power 1, that's 10. So there's 10 decimeters in a meter, or 10 decigrams in a gram, or 10 deciliters in a liter. Centi is the one you're probably the most familiar with. Centi is 100, 10 to the power 2. So there's 100 centimeters in a meter, 100 centiliters in a liter, 100 centigrams in a gram. Milli, lowercase m, that's 1,000, so 1,000 millimeters in a meter, 1,000 milligrams in a gram, so on and so forth. Micro, 10 to the power 6, that's 1,000,000. Now, a quick note on the symbol for this. That is not English. Anybody know what that letter is? It's called a mu. It's Greek. Okay? So, this is a weird little symbol. In order to write it, because it's a little tricky to write, guys, write a lowercase u, and then on the left side of it, give it a tail. Okay, everybody see the lowercase u there? It's a lowercase u, and then on the left side, you give it like a tail. Yes?
So if there's like 10 to the power 6 or whatever micros in a base, which is whatever the thing is, couldn't you just say that, couldn't you put a negative before the exponent and have it in the
Yeah, you could also say that there is 10 to the power of negative 6 grams in a microgram.
Yeah.
Like you can kind of flip it around. So instead of having it 10 to the power of 6 micrograms in a gram, you could say 1 microgram is equal to 10 to the power of negative 6 grams. You can kind of do the reverse. Okay? Nano, lowercase n, 10 to the power of 9, which is a billion. And then pico, 10 to the power of 12, which is a trillion, lowercase p. Okay? You will get this sheet on the test. I've got it up here on the wall. I don't want to hide these from you, and I know since we're all Americans pretty much, it's unfamiliar. So I will give you this sheet on the test. Okay? Trick is knowing how to use it. This is just sort of a reminder about which is which. Because if I like a nanogram, you guys are going to be like, nanogram is what again? Is that 10 to the power of 6? 10 to the power of 9? I can't remember. Okay? So, symbols. Go to the next page. I just want to be clear on how to write symbols because I get some mistakes here. So, what would the symbol be for a kilogram? Kilogram would be kg. Kilogram. All lowercase. Lowercase k, lowercase g. Meter. What's the symbol? Not just an M. Lowercase m. Gram. Lowercase g. Milliliter. ml. Lowercase m, capital L. Millimeter. lowercase for both. Millimeter. Liter. Capital L. Kilometer. Lowercase k and m. Centimeter. That's one you probably know before this. Lowercase c and m. Milligram. Lowercase m and g. Yes?
So how come they use lowercase?
Alright. So let's get used to some of this. The metric system. Let's see if we can review. You guys remember? This is a meter. How big is a centimeter?
100.
Not a tenth.
100.
100th. So 1/100th of this is about that big. Okay? So which is bigger? 63 centimeters or 6 meters? Well, 63 centimeters, I don't even have a meter yet, right? That's less than a meter. So, yep, 6 meters. Next one. Centimeters and meters again. 536 centimeters or 53.6 meters. Which one do you think is longer? Remember that a meter is 100 centimeters. Yeah?
The meters.
The meters, why?
Because it'd be like 5,000 whatever, wouldn't it?
Yeah, it would be in the thousands, wouldn't it?
Yeah.
Because it's basically timesing the 53.6 by 100, right?
Yeah.
So you'd have like 5,000 something. So that one is in fact bigger. Why don't you guys take a moment and go through and do the rest yourself. I'll walk through the answers in a moment. Okay. 5 grams or 508 milligrams? Which one's bigger?
Never mind. I read that.
If it was centigrams, then yes, but it's not.
That's what I was thinking.
Since it's milligrams, there's 1,000 milligrams in a gram, so we have less than a gram with 508 milligrams. So 5 grams is actually bigger. 43 centigrams or 5 grams? How many centigrams are in a gram? 100. So 43 centigrams, we have less than a gram. Versus 5 grams. 5 grams is bigger. 1,500 milliliters or 1.5 liters. They are the same. There is 1,000 milliliters in a liter. So if I have 1,500, I have 1 liter plus a half a liter. 1.5 liters. 3.6 meters or 36 millimeters. 3.6 meters, 36 milliliters is pretty small. Okay? 56 centimeters or 5.6 meters. 5.6 meters. 7 grams or 700 milligrams. 7 grams. Just trying to get used to some of the sizes here. Okay? Notice, guys, if we have a larger unit, like right here, grams is larger than milligrams. this is larger than these, so I have fewer of them to actually be more. Okay? The smaller the unit, the more of them I'm going to need in order to like get a significant amount. Okay, so these small units sometimes you have thousands, if not millions of them in order to equal a gram. Okay? Now, I am not just teaching you guys the metric system today. We're actually hitting two birds with one stone. We're talking metric system, but we're also talking about something called dimensional analysis. Dimensional analysis is a process that you can use to convert units from one to another. And we're going to be using it for most of the year. There's going to be a lot of converting, and it's a process that I use all year long, especially in Chem B. We're going to like start stoichiometry, and we're going to be doing a lot of dimensional analysis every single day. So I just want to explain how this works. First off, a conversion factor. What that is a factor or a fraction which relates two units to each other. Okay, so I want to write a conversion factor. I want to write two of them for grams and milligrams. Now, how many milligrams are in a gram?
1,000.
1,000. So 1 gram equals 1,000 milligrams. That's the information you're going to get from that sheet on the previous page that tells you what millis are and things like that. 1 gram is equal to 1,000 milligrams. Now, what I mean by write a fraction with this information, I want to write the two parts of this over each other. So there's two possible fractions here. You can have 1 gram over 1,000 milligrams, or you can write it as 1,000 milligrams over a gram. Basically, the two parts of this, one on top and the other one on bottom, and then flip them. Two possibilities. Now, this is a fraction. It's a fraction of 1. Because 1 gram equals 1,000 milligrams, I'm putting two things that are equal, one on top, one on the bottom. And in theory, if I actually did this, 1 gram divided by 1,000 milligrams, I'd get 1, because they're equal. They're the same thing. Okay, so it's a fraction of 1 here, if that helps you guys kind of understand what I'm doing here. Just a second. So I want you guys to see if you can do this for the next one. Meters and centimeters. How many centimeters are in a meter? 100. So 1 meter is equal to 100 centimeters. I want you guys to write the two fractions, the two possible conversion factors for this unit. Meters and centimeters. Okay? So here they are. A meter over 100 centimeters, or 100 centimeters over a meter. So these are two fractions comparing two units. How they're equal. That's what a conversion factor is. Why are we learning this? I'll show you in just a second. So here's your first example problem. If I want to convert 2.3 kilometers to meters. 2.3 kilometers to meters. First off, I have to do what we just did. How many meters are in a kilometer? How many meters are in a kilometer? 1,000. 1,000 meters, 1 kilometer. Okay? So I'm going to write two conversion factors here. The first one is 1,000 meters over a kilometer. Or I could write that as 1 kilometer over 1,000 meters. Two possibilities. Now here's the way dimensional analysis works. You take the measurement that the problem gave you, or the measurement that you made, that you want to convert. In this case, 2.3 kilometers. Okay? 2.3 kilometers, and you are going to times it by one of these two fractions. Times it by this one, or times it by that one. The one that you want to times it by is all based off of this unit right here. Okay, it's 2.3 kilometers. That unit right there is kilometers. Okay, I want to use the fraction that I wrote up here of these two that has kilometers in the denominator. So which one has the kilometers in the denominator? That one, right? So if I have kilometers, I want to use, of these two possibilities, the one which has that same unit in the denominator. Okay, I'll get to why that is in just a minute. So I'm going to take 2.3 kilometers and times it by this fraction, 1,000 meters over 1 kilometer. So 2.3 times 1,000 equals 2,300. Divided by 1 is still the same number, 2,300. Everybody with me so far? So let's talk sig figs. This number here has 2 sig figs. How many do these have? Do they? Here's the problem. Everything on that sheet, every time you use one of these conversion factors, it's going to look like you only have 1 sig fig. But there was one rule that we went over last week on sig figs, which we didn't spend a lot of time on, and that is definitions. The definition of a kilometer, the actual definition of it, is 1,000 meters. Not 1,001, not 1,000.003. It is exactly 1,000 meters. Which means any of these conversions that we use here, those are definitions. So they have infinite sig figs. As many as you want. So we are not actually limited by this. We are limited by this. So my answer over here should have 2 sig figs, which it actually does, because these 2 zeros on the end are not significant. It's just the 2 and the 3. So most of these, the sig figs are going to be equal to usually what you start with over here. Okay? Now, my units. Let's go back to the reason why I did the kilometers on the denominator. I had kilometers, I wanted it on the denominator. The reason why, guys, I'm taking kilometers and I eventually divided it by kilometers. Everybody see that? This is a fraction. So timesing it by a fraction, I take this and divide it by, or times it by meters and then divide it by kilometers. So kilometers divided by kilometers, I'm actually canceling out kilometers, and I'm just left with meters for a unit. Gives me 2,300 meters. Okay, so next problem. Convert 5.47 grams to kilograms. First I got to know how many grams are in a kilogram. 1,000 grams are in a kilogram. So I'm going to write both of my conversion factors out. Both of my fractions. First one, 1,000 grams over 1 kilogram. The other one, 1 kilogram over 1,000 grams. So there's my 2 possibilities. Now I'm going to actually start my problem. 5.47 grams, and I'm going to times it by one of those 2 fractions. Which fraction? We'll call this the first one, second one. Okay, first one or second one? Sydney? Second one. Why? So because this is a gram here, I want to pick the one with grams in the denominator. That way it'll cancel out. I'm going to have grams and then I'm eventually divide it by grams, so it'll cancel out. So I want this fraction here. I'm going to times that by that fraction. Okay? So doing the math, 5.47 times 1 is 5.47. Divided by 1,000 is 0.00547. That has 3 sig figs. That has infinity sig figs. So my answer should have 3 sig figs. Does it have 3 sig figs? Yes, it already does. I'd say like 95% of the time, guys, when you do these conversions, your answer already does have the correct amount of sig figs. Unless you added zeros in there somewhere, or added pointless zeros that you shouldn't have. Okay? Units. Grams cancel. I'm left with kilograms, so my answer is in kilograms. Questions? Your turn. Okay, I want you guys to try this one yourself first. So convert 2.34 grams to centigrams this time. Give you guys. So first off, grams, centigrams. 1 gram is 100 centigrams. So my 2 possible fractions here. 1 gram over 100 centigrams or 100 centigrams over a gram. So I set up my problem. I take 2.34 grams, times it by one of these 2 fractions. Which one? Number 1 or number 2? Number 2. So, because it's got grams on the denominator, and I have grams. So I'm going to times it by that one, 100 centigrams over a gram. 2.34 times 100 is 234. Divided by 1 is the same answer, 234. Okay. Grams cancel, or excuse me, sig figs first. I got 3 sig figs, infinity sig figs, so my answer should have 3 sig figs. It does. Grams cancel for my units, so I'm left with centigrams. Final answer, 234 centigrams. Questions? All right, everybody take a look at number 4. On the next page. Okay, this one's a little more complicated. Convert 4.72 milliliters to microliters. This may not look much more complicated, but here's the complication. If you look at the sheet, everybody flip to that sheet with all the things on there. Milliliters. Find milli on there. It tells you that there's 1,000 milliliters in a liter. It doesn't say anything about how many milliliters are in a microliter, does it? If you find micro, it tells you how many microliters are in a liter. Doesn't say anything about milliliters. So nowhere on that sheet is there a direct way to go from milliliter to microliter. But we do have 2 of them. 1 liter is equal to 1,000 milliliters, and 1 liter is equal to 1,000,000 microliters, which is 10 to the power 6. Casper? Okay, so we've got 2 conversions here. In order to do this problem, because we have 2 different conversions, we're going to treat it like 2 different problems, 2 different steps. Okay? So the first step, we're going to take milliliters, and we're not going to find microliters. Instead, we're going to find liters. Once we know liters, then we can find microliters. So 2 different steps. So doing the first step, we're going to do the liter one first. Okay? 1 liter is equal to 1,000 milliliters. So I got my 2 fractions set up there. A liter over 1,000 milliliters, or 1,000 milliliters over a liter. 4.72 milliliters times one of those fractions. Which one should I use? Number 1 or number 2? I should use number 1 because I have milliliters. Since I have milliliters, I want the one with milliliters in the denominator. So this is the one with milliliters in the denominator. This one's got liters in the denominator. So there's my fraction. I'm going to take this, times it by that fraction. So 4.72 times 1 is 4.72. Divided by 1,000 is 0.00472. Milliliters canceled, so that is 0.00472 liters now. So that's the first step. The second step is now that I have liters, I'm going to convert that into microliters. Okay? So I'm starting with this answer here, not this answer. I'm starting right here, just continuing the problem. All right, I'm going to erase these fractions here. So my two new fractions with this other one, a liter equals 1,000,000 microliters. So it's either 1,000,000 liters over, or 1 liter over 1,000,000 microliters, or 1,000,000 microliters over a liter. Which one? Number 1 or number 2? Number 2, because it's got the liters in the bottom and I have liters down here. All right? So I'm going to times it by that fraction. 0.00472 times 1,000,000, 10 to the power of 6. And then divide that number by 1. 4,720. $4,720. Now, let's take a look at sig figs. That one's got 3. Both of my conversions have infinite, because they're definitions. It's the definition of a microliter and a milliliter and a liter. So how many should my answer have?
3.
Does it?
Yes.
Yes, it does. Okay? So it already has the correct number of sig figs as long as I don't add any decimals or anything. Okay? Last thing for units, liters cancel. So I have microliters. Okay, microliters. Questions? Okay, now, there's actually a second way to solve this problem. I just want to show it to you guys because it's perfectly acceptable. You can do it just the way I just showed it to you, and that's fine. But the other way to solve this problem is, if you guys remember from algebra, that if two equations equal the same thing, then they can equal each other. So a liter is equal to 1,000 milliliters. A liter is also equal to 1,000,000 microliters. That means 1,000 milliliters is equal to 1,000,000 microliters. Since this equals a liter and this equals a liter, this is equal to that. All 3 of these are equal: liter, milliliters, and microliters. So I could also just rewrite it out as one thing here: 1,000 milliliters, 1,000,000 microliters. So my two fractions here, 1,000 milliliters over 1,000,000 microliters, or 1,000,000 microliters over 1,000 milliliters. And I set it up the same way. 4.72 milliliters. I'm going to use the one with milliliters on the bottom, which is that one. 4.72 times 1,000,000 equals a number. I'm not quite sure what. Okay, 4.72 million, I'm assuming. And then divide that by 1,000. Get you the exact same answer you had before, 4,720. This is a perfectly acceptable way to do it. But it all depends on your preference, honestly. I don't care if you do it this way or the first way that I showed it to you. Okay? Questions on this method? Hardest part about this is realizing that since they both equal a liter, they equal each other. Okay? All right, next example. convert 6.59 centimeters to kilometers. So looking up these, there is no centimeter to kilometer on that sheet. There is a centimeter to meter, and there is a meter to kilometer. There's 100 centimeters in a meter, and there is 1,000 meters in a kilometer. You guys see this is going to be a two-step again? Because I've got two different equations here. Now this one absolutely has to be done as a two-step problem. Because this is 1 meter and this is 1,000 meters. Okay, so the way that these two are written right here, it has to be a two-step problem. If I could figure out how many kilometers are in 1 meter, then I could do it in one step like I did before. Okay, so if you can figure out that it's 0.001 kilometers is equal to a meter, then you'd be good to go that way. But writing them out like this, I'd just do it in two steps. It's easier. Okay, so the first step's going to be centimeters to meter. Second one's going to be meter to kilometer. So I'm going to start with my two fractions for the centimeter to meter one. Okay, 100 centimeters over 1 meter, or 1 meter over 100 centimeters. Write out my number, 6.59 centimeters times one of those two fractions. Which one? First one or second one? You should be using the second one, because that is a centimeter, so I want the one with centimeters in the denominator. Okay? Couple of tips. I'm going to kind of pause for a second. I get a lot of people who work through these and they decide they're just going to write numbers and they're not going to write units. Can you guys see writing down the unit so you can figure out which of these fractions is important? The biggest mistake people make is not writing down those units and then confusing like which does the 100 go with the meter, or goes with the centimeter, or does it go with the kilometer? Which one does the 100 go to? So just write the unit that you're talking about for everything, and there will be a lot less confusion. Okay, a lot less confusion. I know some of you guys are like, whatever. That's going to be your problem, and that's going to be your downfall. You'll be a lot less confused if you write those units. So 6.59 times 1 is 6.59. Then divide that by 100, and you get 0.0659 meters. Centimeters cancel, so I'm left with meters. The next step, step number 2, I'm going to take the 0.0659 meters, this number here. Don't use this answer, use your answer. It's a two-step, so take your answer from the first step. This many meters to kilometers. So my two fractions here, 1,000 meters equals 1 over 1 kilometer, or 1 kilometer over 1,000 meters. So here's my two fractions. Which one should I use? Second one, because that's a meter. So since that's a meter, I want to use the second one. Okay? So 0.0659 times 1, same number. Divide that by 1,000, gets me 0.000659. Meters cancel, so it's kilometers. 0.000659 kilometers. How many sig figs should my answer have? 3. Because that has 3. Those are infinity. So my answer should have 3, does it? Yes, it does. Because the zeros in front don't count. It's just the 6, 5, and the 9. Okay? Now that's actually a pretty small number, guys. That's a pretty small number. When you start to get something with that many zeros in front, it might be a good idea to start writing that in scientific notation. So what would that number be in scientific notation? 6.5 times 10 to the power of negative 5 is what that would be in scientific notation. When you get something really small like that, that's when you might start thinking about putting it in scientific notation. So you don't accidentally like write the wrong number of zeros. Questions? Yes?
On a tester quiz,
Hmm?
are we going to have to write it in scientific?
All right, last example. I want you guys to try this one. I'm going to warn you, this is a two-step problem. Okay?